Okay, guys, so we just changed a little bit the perspective. Balázs helps me here because this is, I think, the most complicated stuff of the whole story. So what we are doing right now, we prepared everything, and I just like to try to explain you how we should transpose all the coordinate system that this whole stuff will work. So if you think about, we got a coordinate system here right now. So we have an origin, an X, and the Y direction, and this is basically exactly the same what we have done earlier. So we just defined the X and the Y coordinates and this layer coming from the wooden plate. So what we will do right now, we will come with this workpiece. This is the same one. I just showed this. This is exactly one by one the same one what we have right now in the gripper. So if you take a look, I will just get it on this manner. And if I mirror this, then we have to turn around. So what I will do, I will just remark it that this corner is the X direction, this corner is the origin, and this corner is the Y direction. So I will just do this here. I just put it here, you back. So you will see on the wooden plate, this was exactly the same coordinate system. We have the origin, X, X, Y, Y, okay? Just to make it for you clear. So this was how we just defined the coordinate system and the frame. And if we just flip it over, then we have here an origin, we have here an X, and we have here a Y, okay? So once again, X, Y, and the origin. Very crucial, okay? Why it is so? We have to define this frame and this coordinate system always on the workpiece. So as we have a remote TCP or stationary tool stays somewhere, so we can't use it for any kind of reference point. So therefore, we have to operate with the frame on the workpiece, what we will process later on. In this case, we have done this in the gripper, and right now we just copied exactly the origin, the X and the Y points to the secondary workpiece. Extremely important, the position, the distance and the angles must be exactly the same. Like on the workpiece you have used for the teaching, for the setup of this system. If you're using somewhere the Y and somewhere the X, it will never work. Extremely important. These 3 points must be exactly the mirrored one of this here from the robot. I hope that Balázs can capture this. So this here is our origin. This is the X, this is the Y. We have the corners here, origin, X, and Y, exactly the same. Distance is the same. The lines, the angles, everything is one by one the same. So if you have it, you have to define it on your own. It's everything fine. We have a little bit too much cable here around. So, and what we are doing right now, I'm coming to do the first recording to this task. It's very important to understand. We don't have to make any recording for the Easy Automator tool in the workspace of the robot. This is especially important for any remote TCP applications, because you have a big stationary machine, which is most probably very expensive. So you want to work with productive, and therefore we make it possible for you that you can do this whole complete recording offsite. And what I have done here, so we have 2 laser boxes. The one is there and the other one is here. Maybe you can see this despite of the light. And these both laser boxes are scanning this desk, okay? So this is what I'm doing. And right now I have a double-sided tape here that it makes my life a little bit easier. It doesn't matter if I place the workpiece so or so or so. This is all the same because we have the frame on our workpiece. The only stuff why I'm using this, that it's not just moving around, because later on I have to touch up the corners with the teach pen. So I will show you in the reality and on my screen what's happening. So from at this point, this is pretty the same. Wait a second, I just have to find my mouse. Where's the mouse? Here's the mouse. and here's the mouse. Okay, I'm just starting the Steam VR, and I'm just switch on the pen, which is lighting up blue at the moment, and as soon as my device will be found, this turns green. At this moment, I'm using only one laser box, this one base station, because in certain cases we have the experience that we can get a higher accuracy if we are using only one. Maybe this is depending on the interferences, or I don't know what. Anyhow, if we can minimize the amount of the reflections in the surroundings, then it is a good stuff. So what we are doing right now, I have to create a so-called launcher. To do so, I have to start the RobotDK app. This will be renamed soon to Easy Automator. We already done all the preparation, so you can see here that we have a menu or a button, Create Launcher, and you can give a name what you want. I let it with the RobotDK code. So what is the tool? The tool is not the tip, but the tool is the workpiece TCP, okay? And the frame is not the wooden plate, but this is the workpiece. So very important, you have to activate the remote TCP option, and the robot type is a 6-axis one because this is the cobot, okay? So show welcome window. If you want to ignore the first window, then you can switch this off. I'll just let it so as it is, and then I just hit generate, and you will see I have a launcher called RobotDK call. In this case, within my RobotDK file, I can save it, and if I double hit it, the recording will be started automatically. That means we will get opened the RobotDK window, and then we are just I just hit the start recording. So I'm just coming to the origin, X, Y. Right now you can see that the robot is already moving around, and I'm coming back to the origin. So the accuracy is 0.86 millimeters, okay? So you can see that the robot is moving around like I just do this. I'm coming to an approach position. I hit 1. I'm coming to the origin point. 1 point in between, 1 corner, 1 point in between, 1 corner, and 1 point in between. Bam. I don't want to overstress this, we just let it so. And here with an additional approach position, I just come out, and then I just hit finish recording. So that's all. You can see, okay, we just get this message because only one VR box was, or one laser box was connected, and we just load the communication, which is not bad because I just decided to end the recording. And here right now you can see already that the robot can go over, and I think I have just done a failure because we were started from the welcome screen. So I will just come back. I delete all this stuff which we recorded. And I just create the launcher again without the welcome window. I just wanted to show you that if you make this failure, you will get like this one, what you can see. And here's one additional stuff. I was using the Elite Home as a home position, but in the RobotDK app, I created or I defined it as Home Elibot. So this is wrong. I just copied the name from here. I just come into the options. I define as a home position exactly the same stuff which I defined earlier in the RobotDK file. I save it. I recommend you the default rounding. This is the smooth parameter in RobotDK to set it to 0. This might just make some trouble. and I just hit save. So I have to restart it again. This home position we don't need anymore. So, and I just start over again. And I create the launcher again. So create launcher. I just rename it ProPath Record 2 to make it different. So we have the workpiece TCP, and we have the workpiece as a frame. This is a remote TCP, and I don't want to use the welcome window and generate the launcher. Here you can see the launcher, and I just start it again. So right now you can see as I double clicked it, we are just getting indeed directly into the recording phase, which I highly recommend to do so. So I'm coming to the 0, to the X, and to the Y. And I'm coming to the 0 again. So the accuracy is not as good. This is 1.4 millimeter, which I think on this workpiece, this is still fair enough. So I'm just coming to the approach position and try to hit 0, point in between, X, point in between, point in between. And I'm just coming out here. So, and this should be the whole recording for now. And hopefully we can see, okay, the robot really can reach all these positions. Okay, you can see that the TCP is rotating. We will handle this in a later step. We just wanted to test this out if we can do this recording. It seems to be the case. So how you can see this? I hope so. You can see this on this way quite good on the screen, what is happening. So we are really following this outline. And after a short break, we will come back to you and we will show you how it looks like in the reality.